Hello, today I'm gonna be drawing and naming four constitutional isomers of C4H7Br, excluding any alkanes. So let's see. C4. So for C4, we can first of all, I think it would be helpful to see if it has a ring or a double bond, which is excluding the double bond, but to see like the degrees of unsaturation. So then the formula would be 2C plus 2 minus plus nitrogen minus hydrogen minus a halogen divided by 2. So here we will have 2, 4 plus 2 plus 0 minus 7 minus 1 divided by 2. The Br will be the halogen here. So then we have 2, 4, 8, 10. 10 minus A is 2, so 2, 2. It's 1 degree of unsaturation. Therefore, it should have a ring. So, according to that, we can, let me resize this. We can proceed, and since it's C4H7Br, we can go and draw a cycle. And then you will have 1, 2, 3, 4, 5, 6, 7, and then this one will have the Br attached. So then that would be the red dots will be the hydrogens, just to have a better understanding. 1, 2, 3, 4, 5, 6, 7 hydrogens for 4 carbons, and then the Br. So that will be one of them. And in order to name this, we have to actually, I think we should draw all of them and then name them. No, draw and name them. So then, in order to name a compound, you should circle the parent, which would be this little square that you see here. So then, since it is a cycle, you have to count the number of carbons, which is 4. So the number for 4 is the prefix. It's bu. So then it will be, since it's a cycle, it will be cyclobutane. Super important. Okay, so then identify the branches, so they're just one, and for example, just this is 1, 2, 3, 4. And if you do clockwise, it's still gonna be 1. So then it's just 1 bromo for halogens. The subsequents, there are halogens. They end in omo. So then it's 1 bromo. Essentially it would be a simple way, so it would be bromo cyclobutane. So then let's draw an isomer, which you can also do it this way. this will be 3 carbons, and then we will be missing 1 carbon, and then the Br that will be attached to the carbon. So Br only needs 1 bond, only takes 1 bond. So after this then in order to name it, again you have to, well, just to verify, we have to also verify the number of hydrogens. So we do have the 4 carbons and the Br, but let's just see if it has 7 hydrogens. So we'll wait, 1 here, 1 here, 1 here, 1 here, 1 here, 1 here, 1 here. 7. That will be a total of 7. So then let's just do this one. Just start the numbering in the parent function. So the one with the most carbons, hydrocycle. So then since it's 3, that's gonna be cyclopropane. Right, so then you go number it. It's gonna be 1 in both ways. So then you just circle the ramifications, which would be C. And then that one has bromine. So then for this ramification, the parent will be methyl, and that will be the parent for that one. And then the ramification of bromine, like from carbon is still on carbon 1, since it's the only one that's the longest ramification of carbon. So then that will be 1, since located at 1, bromo, and then the parent function, that will be methyl for that one. The subsequent, that's why it's in IL. And then you go and add the parent, other parent for the big one. So then the next possible isomer, let's see, it will be the same cycle. There will be 3 carbons, then a carbon attached, and as I previously mentioned, bromine can only be attached to like 1, so only have 1 bond to the halogen. So then to make it different than the previous one, we're gonna put it on a different carbon. Now we're gonna count how many hydrogens it has. So then it will be so each carbon can have up to 4 bonds. So then is 1, not up to 4 bonds, but attached to 4 atoms. So this one has 1, 2, 3, so then 1 hydrogen here. This one has 2 hydrogens. This one has 1 hydrogen, and this one has 3 hydrogens. So 3, 3, 7. And it has 4 carbons and then the bromine. So therefore, again, we circled the parent function, the number of carbons, the longest chain of carbons. Interrupted. So then that will be again cyclopropane. So then we have 2 ramifications. So this one, it's okay. We have to do the numbering. So then here we have 1, 2, 3, and then on this one we have 1, 2, 3. So you have to do it clockwise, like clockwise, and then counterclockwise. So this will be counterclockwise, and this will be clockwise. So then you take both of the numbering that you did. So for example, 1 and 2, and then the counterclockwise will be 1 and 3. And those are the numbers where the 2 branches are. So BR is in 1 for both, and then C is for red is in 2, and for purple is in 3. You're gonna take the one with the smallest number, so then it will be that one. Okay. So then, again, when it's a subsequent and it's a halogen, it's a halogen. The N in HOMO. So then will be again 1 bromo. And then for C, it will be, since it's 1 carbon, it's gonna be 2. We're gonna 2 methyl. And then this will be 1 methyl. 2. Oh wait, I'm sorry. I also forgot the number, like the one that comes first in the final naming. It's alphabetically ordered. So B comes before M. So then bromo comes first. So it's 1 bromo, 2 methyl, and then you add the cyclopropane. 2 methyl cyclopropane. I forgot to put this in parentheses. It's complicated. It's just a complicated subsequent that they were asking. This one is a complicated subsequent. And then for the final isomer, you kind of have to be creative on this. So then we already try with C and BR. We try C, BR. What would be a other possible combination that would still give us 7 hydrogens, 4 carbons, and 1 BR? So then you can have. So remember that BR only can connect to 1. So then let's try this one and verify with hydrogen how many hydrogen, if it accomplishes the number of hydrogens the compound has. So then 1, 2, 3, 4, 5, 6, 7. So you cannot add it here because, for example, this carbon already has C, this carbon, and Br. So it has its 4 atoms attached, four bonds. So yeah, and then this one has 2. So then the other hydrogen is there, hydrogen is there. So then for naming, you circle the longest interrupted carbon chain. Again, this is cyclopropane. So then you circle the two branches out of the parent, and then you do the what is it, the numbering again. Either way, clockwise and counterclockwise would still be the same. They're both attached on the same. So then it will be on the same carbon on the first one. So it will be 1 bromo again, then 1 methyl, 1 carbon. So reminder again, halogen ends in OMO as a subsequent and one subsequent. 4 carbons. Everything ends in YL.
Son las 7:10.
So then, again, we do this alphabetically. Bromo, it comes before M. So it would be 1 bromo, 1 methyl, cyclopropane. And that would be the 4 isomers and their naming.